Hello and welcome back. We are about to finish conditional statements and we have one last topic, which is recursion. Now let's see what recursion is and how we use recursion in programming. After recursion, we will have our quiz. So go to Jupyter Lab and our title is recursion. Let me define what a recursion is. A function, as you may know, can call other functions. We already know this. What its need is, the function also can call itself. The function will call itself. We call this recursion. So, and let's write an example. A function which prints backwards from a given number up to 0. It will call itself, and every time it will print another number, it will come backwards up to 0, and we will see example of this. This is recursion. One very important topic in recursion. Let me write it. It's really important. In recursion, you have to set an exit condition. Which is very, very important in recursions. Otherwise, if you don't set an exit condition, otherwise what will happen? The function will call itself up to infinity. Which is infinite loop, which we call infinite recursion, by the way. Okay, we have to set up an exit condition. Let's see with an example. Let's see recursion and exit condition. Example. Now we will count down, def count down, and we will take a number. From that number, we will count down up to 0. So first thing first, the very important part is exit condition. Every time in recursion functions, the first line of code is check exit condition before doing anything else. If n is smaller than or equal to 0, I mean if we are in 0, if now the incoming parameter is 0, we will print end of program. Okay, we will do nothing. We will print end of program and we will return. That's all. If n is 0. Now, else, if n is not 0, which means if n is not smaller than or equal to 0, which means it's greater than 0. In any case which is greater than 0, first we will print n. Then what we will do? We will call ourselves. It will call itself, but this time with n-1. Okay, that's recursion. The function calls itself, but this time n-1. Now n-1 will come and it will check. If it's not still 0, it will again print and again call the function, call itself n-1. Now let's run the function with, let's say, 5. Count down 5. If I run this, as you see, it first come into the function. It checks if n is smaller than 0. No, it will print n, which is 5. Then it will call the function with 4. N is equal to 4. 4 will do exactly the same thing. It will check the condition. This is not succeeded, so it will move on to else statement. It will print 4. Then it will call with 3. Up to when? Up to 1. When n is equal to 1, it will come here because this is not still evaluated. But here, when n is equal to 1, it will print 1, then it will call the function with 0. When it calls the function with 0, 0 will come here and it will be evaluated, and 0 will print end of program, and it will return, it will exit the program. That's why we call this exit condition. That's how we set recursions, by the way. So let's call it with 10, let's say, not 5, 10, and let's see exactly it will do the same thing, and whenever it comes to 0, it will stop. Okay, now let's create another function. Create another example, by the way. Create a function which will print the text parameter given to it. We will enter a text into parameter, and it will, to the function, and it will print the text. The function will write this text. Will write this text number n times, which n is another parameter. N is second parameter. Okay, it's integer. So the function will take two parameters, and let's name it as write text. Write text. It will, first parameter is the text to write. Second parameter is the n, number of times you want the function to write the text. Okay. Now first thing first, the exit condition. Never forget this in recursions. If n, again, we will check if it's smaller than or equal to 0, we will return. We will do nothing, okay? Because we don't want to print anything if n is 0. We will just stop. Else, now we will print the text. Then we will call it again. The function will call itself again with the same text, because we will write the same text again, but this time n-1. So it will come again, it will print, and it will call itself again, exactly recursion. So let's call this function write text. This time our text will be, let's say, machine learning. Now n is, let's say, 5. We want to write machine learning 5 times. Okay, it will the first time it will write, and it will call with 4. 4 will write and call with 3. So 5 times we will write machine learning, as you see. Okay, that's how we set up recursion. Now let's print the numbers also. Let's print the numbers for you to see in which number it's printing the text. Now we will write, not just print text, we will put here a string format. This will be the number, this will be the text. Okay, dot format, n is here, text is here, and I will close the parentheses. Okay, that it will write as 5 machine learning, 4 machine learning. If I run this, if I call the function again with the same parameters, if I run this, as you see, it now prints also the numbers. Okay, so let's see, we forget to put exit condition. Okay, let's assume we did not set a proper exit condition. Let's see what happens if you do not set an exit condition. You will get an error, as you may expect. Let's see what error is this. Okay, let's define a function, def, up to 100, let's say, up to 100. This time we want to write the number starting from n up to 100, okay? And the first thing I should do, normally, I should do the exit condition. Now I omit this. I forgot to set exit condition, no exit condition, okay? Now let's see what happens. Now I will print n, the number come in as parameter, then I will call the function with n-1. Okay, that's all. I print n, I call the function n+1. Sorry, I'm incrementing the number up to 100. That's my intention. So let's call this function and let's give 80. So what I am expecting is it will print 80, then 81, then 82, up to 100. But I intentionally forgot exit condition. So let's see what will happen. If I run this, it will print, but Python will stop it at some point to prevent you crashing all your system's memory. It will stop and it will raise. As you see, still your kernel is busy. This one is full circle. Your kernel is still trying to do the operation. Finally, it will stop, and I don't want wait it to stop. I will stop the kernel manually. As you see, restart the kernel. Okay, and what error you will get here? Let me close this. Is recursion error. Okay, it will give you recursion error. Infinite. It will say it says infinite recursion depth, maximum recursion depth exceeded, something like that. Okay, so you will get recursion error if you don't set a proper stop exit condition. Okay, so let's do it in the right way, then we will finish this lecture. Now I have to set the exit condition. Okay, the exit condition, I will check if n is greater than 100. Okay, so if n is 101, I will stop, return. Else, if it is not still bigger than 100, I am still less than 100, then I will do exactly the same thing. I will call my recursion. Okay, now call this again with 80. Now if you run this, you will start from 80, 81, then you will print 100 and it will finish. Okay, I mean that's enough also for recursion. Now we also finished this, and now it's time for you to solve the quiz of conditional statements. Please try to solve it by yourself, then join me in the quiz solutions. See you there.